Okay, we have question 10. It says two small identical spheres A and B are suspended on long silk threads as shown in the sketch below. The spheres carry charges of positive 3 times 10 to the power of negative 6 coulomb and negative 2 times 10 to the power of negative 6 coulomb respectively, as we can see from the diagram here, right? Then 10.1 says which sphere has an excess of electrons. When it comes to identifying which one has an excess of electrons, let's first understand what is going on here. We know that when a sphere is positively charged, it indicates that there are more protons than the electrons, right? And then when a sphere is negatively charged, it indicates that there are more electrons than the protons. So if you are looking for the one with an excess of electrons, it has to be the one that is a negative, right? So B here in this case is the sphere that has an excess of electrons. 10.2 says the two spheres are allowed to touch. Will the electrons be transferred from A to B or B to A? Now, when it comes to this, we have to understand that the flow of electrons is always from the sphere with an excess of electrons to the one that has a deficiency of electrons. So we have already identified in 10.1 that B has an excess of electrons. That means that A has a deficiency of electrons. Now, the flow of electrons has to be from B to A. Now 10.3 says the spheres are now separated. Calculate the new charge on sphere B. So now we want to calculate the new charge on sphere B. But then that happens after A and B have came into contact. Now we understand that since this is a positive and a negative, the two spheres will attract each other, come into contact, and then share the electrons equally amongst themselves, right? So now we want the new charge on sphere B, which we know from the principle of conservation of charge is that we know that the new charge on sphere B will also be the same magnitude of charge on sphere A, right? So that means we are calculating the new charge on each of these spheres. Then for 10.3, we have the formula to calculate the new charge. We have the formula that goes Q new is equals to Q1 plus Q2 over 2. So for Q1, we're going to substitute the magnitude for sphere A, which is 3 times 10 to the exponent of negative 6. Then plus substitute for sphere B, that's negative 2 times 10 to the exponent of negative 6, and then over 2. So if we punch this in our calculator, we have 5 times 10 to the exponent of negative 7 coulombs. So this is the new charge on sphere B, but then it is also the new charge on sphere A. Okay. So for 10.4, it says now calculate the number of electrons transferred during contact. So from the previous question, we learned that the new charge that we calculated on sphere B will also be the new charge for sphere A. So both sphere A and sphere B have the same magnitude of charge, right? Hence, after contact, they then separate. Then to calculate the number of electrons transferred in 10.4, we must use the formula that goes N is equals to change in Q over E, right? Now, what is the E here? The E is a constant, right? Which is always negative 1.6 times 10 to the power of negative 19 coulombs, right? So it always appears in your data sheet at the back of the paper, right? So this is a constant. You always substitute it like this. Then using this formula, the change in Q, when I say QF minus QI. Now the QF value will indicate the new charge of each sphere, and then the QI is the initial charge, right? So this is the charge before the two spheres have came into contact, and this here is the charge after the two spheres have came into contact. Then let's substitute the final charge, or the new charge, is 5 times 10 to the exponent of negative 7. So for this one, we are using sphere A. Let's use sphere A. Then minus 3 times 10 to the exponent of negative 6 over negative 1.6 times 10 to the exponent of negative 19. Now, if you punch all this in your calculator, you have 1.56 times 10 to the exponent of 13 electrons, right? Now, you might be wondering, what if we use sphere B? Will we still get the same answer? So now let's try it using sphere B. So for sphere B, again, the same formula, N is equals to change in Q over E, right? So we have the Q finally minus the Q initially over E. Now, what is the Q finally? This is the new charge after separation, which is still the same magnitude, 5 times 10 to the exponent of negative 7. Then minus, for this one, we're going to say minus negative 2 times 10 to the exponent of negative 6. Then all over negative 1.6 times 10 to the exponent of negative 19. Now, if you punch this one, it will still be the same magnitude, but then this time it will come out as a negative. Now, what you do when it comes out as a negative, you ignore that negative sign and then you just write it as a positive, because always the number of electrons should always come out as a positive integer, right? So you're gonna ignore the negative there and then write it as 1.56 times 10 to the exponent of 13 electrons. And then you can see that working with either sphere, you still get the same answer.